In this video, we pay attention on how to find the condition number of a 2x2 symmetric matrix. We have this matrix A, and we want to find what is the condition number of this matrix. So first, we observe that this matrix, we take the transpose. So the rows become columns. And we get that A transpose is equal to A, so A is a symmetric matrix. Now, in order to find the condition number, we need the condition number is equal to the infinity norm of matrix A times the infinity norm of the inverse matrix A minus 1. How do we find the infinity norm of a matrix A? We find the maximum of the following. So we go to the first row and we add the elements that they are in the first row in modulus, in absolute value. And similarly, we do the same thing for the second row. So here the sum is 3. So the infinity norm of this matrix A is 3. What we also need to find what is the inverse matrix and then to find the infinity norm. So how do we find the inverse matrix? 1 over the determinant of the matrix A, and then what we do is that we flip these elements on the main diagonal, we flip them, and here we we put a minus on this bit here, minus 2, minus 2. The determinant of A is 1 minus 4 equals minus 3. So the inverse matrix should be the following. This is a scalar multiplication, so we can put this inside the matrix. As a consequence, the inverse of a matrix A is this one. We calculate the infinity norm. So we add these two elements in the first row in absolute value. And similarly, we do that for the second row. This is 1 and 1. So from here we deduce that the infinity norm of the inverse matrix is 1. So the condition number of the matrix is the infinity norm of matrix A times the infinity norm of the inverse matrix. We get 3. The condition number is equal to 3. If the condition number is near 1, we say that A is well conditioned. If the condition number is greater than 1, A is ill conditioned. There is another way to find the condition number by calculating the eigenvalues of the matrix. So we take the characteristic polynomial, it's 1 minus lambda squared minus 2 squared. So this is 1 minus lambda minus 2 times 1 minus lambda plus 2. We can remove the brackets here. Minus 1 minus lambda times 3 minus lambda. We take the minus outside and we put the minus here. So the characteristic function here is lambda plus 1 times lambda minus 3. We take this equal to 0 and we get that lambda 1 is minus 1 and lambda 2 is 3. The condition number is lambda max over lambda mean in absolute value. So the lambda max is 3 in absolute value and minus 1. So the condition number is 3. Using the eigenvalues, finding the eigenvalues and using the eigenvalue approach.